Is there some noise?
No.
Okay. Okay, so we want to show every convergent sequence of real numbers is bounded. So we have started with an arbitrary sequence. Okay, xn is my arbitrary sequence which is convergent. Convergent means there exists some x belongs to R such that xn converges to x. Okay, so since it is convergent, for every epsilon there exists some natural number satisfying the condition. Therefore, in particular, epsilon is equal to 1 also there exists some natural number which satisfying the condition. Are you getting this? Okay, let me erase this. Instead of writing this, I will write so consider mod of xn. Mod of xn, how can I write? Mod of xn minus x plus x I can write.
Yes, ma'am. Yes.
This is less than or equal to mod of xn minus x plus mod x I can write.
Yes, ma'am.
Now, mod of xn minus x is less than 1 I am having for all n greater than equal to n0. So this I can write as 1 plus mod x for all n greater than equal to n0.
Yeah.
Yes. So now x is some particular real number. X is not varying, na? X is some particular real number.
Yes, ma'am.
So for all n greater than equal to n0 means like this. All this. My xn is bounded. Right? From here onwards. For here onwards sequence, my xn is bounded. Only the problem with these points only means I want to have a real number for which this is I will get bound for this. Only this many remaining, right? These are finite numbers. x1, x2, x3 up to xn 0 minus 1. Xn 0 minus 1. These are finite numbers. Finite number of real numbers.
Yes, ma'am.
Yes. So for all n is equal to n0, I am having this. And now let m is equal to say maximum of x1, mod of x1, mod of x2, mod of xn 0 minus 1. If I take m is equal to maximum of all these things and 1 plus mod x also I take, then can I say mod of xn is less than or equal to m for all n?
Yes, ma'am.
Yes. Now for all n, because you can take m1 for this and 1 plus mod x for this, and then again take maximum of this, say it is m. So instead of writing m1 and this, I taken maximum, m is nothing but maximum of this, mod of x1, mod of x2 and all, and 1 plus mod x. Is that okay? So this implies xn is bounded sequence. Bounded sequence. So every convergent sequence is a convergent sequence of real numbers. We are talking about real numbers, so it is bounded. Is that okay, this proof?
Yes. Yes, ma'am.
Okay. Every bounded sequence is Yeah, need not be convergent. Remark, I can say. Need not be convergent. Every bounded sequence of real numbers need not be convergent. Means converse of the above theorem is not true. So if I want to prove something is not true, then one example if I give, that is also enough. Counter example.
Yes.
Yeah. So can you give example of a bounded sequence which is not convergent? For example,
minus 1 raised to n.
yeah. For example, xn is equal to minus 1 raised to n, which is bounded sequence. Clearly it is a bounded sequence, but it is not convergent sequence. Why it is not convergent sequence?
Oscillatory.
Because you are getting 1 minus 1 1 minus 1 and so on, right?
Yes.
So you can prove this. Take as a homework, prove this. Prove that sequence xn is equal to minus 1 raised to n is not convergent. How you will prove this? Suppose it is convergent. Suppose it is convergent sequence and arrive at some contradiction. Okay. Prove by contradiction. Okay. So today you think on this and tomorrow tell me what is the proof. Or you can send me on WhatsApp group also. Okay. Suppose it is convergent. If you yes.
तिथं युनिक लिमिट एक्झिस्ट होत नाही त्यामुळे ती कॉन्व्हर्जंट नाही असं म्हणू शकतो.
म्हणू शकतो म्हणजे आता ते आपल्याला दिसायला दिसतंय, बट वी हॅव टू प्रूव्ह बाय डेफिनेशन.
करू शकतो.
या मीन्स सपोज इट इज कॉन्व्हर्जंट म्हणजे से कॉन्व्हर्जंट देर एक्झिस्ट सम एक्स लिमिट एक्झिस्ट व्हायला पाहिजे ना. इफ इट इज कॉन्व्हर्जंट देन let xn is convergent, then let xn converging to some x belongs to R. मग आता you are saying minus 1 raised to n converging to some x belongs to R. Then try to arrive at some contradiction. If you assume this, then you will definitely get contradiction. Use definition of convergence. Okay. So today you think on this, and if you won't get, I will tell you. Is that okay?
Yes.
Arrive at some contradiction. Some contradiction. This is hint. Okay. Now we will prove next lemma, which we will require to for next theorem. So first we will prove lemma and then we will prove next theorem. So what is lemma? For any subset A of R, supremum of minus A is nothing but minus infimum of A. Minus infimum of A. Where what is minus A? Minus A nothing but minus A where A belongs to A. You take some set, say for example we will take, let A is equal to say 2 3 5 7. Okay, so what is supremum? Okay, minus A. First, what is minus A? Minus 2, minus 3, minus 5, minus 7. Now what is supremum of minus A for this set? Minus
Minus 2.
2. Yes.
minus
And what is infimum of A?
2.
A. Infimum of A is
2.
2. So supremum of minus A is nothing but minus infimum of A. By example, just you see, huh? We have to prove this. Okay, we have to prove this. This is just for your understanding what is supremum and relation between supremum and infimum. Okay, so we have to prove claim supremum of minus A is equal to minus infimum of A. So how? Let alpha is equal to supremum of minus A. Then what can I say about elements of minus A and alpha? Then alpha must be greater than equal to minus A for all A belongs to A, right?
Yes. Yes.
Or instead of this I will write reverse. Then minus A is less than equal to alpha for all A belongs to A. Then this implies A is greater than equal to minus alpha for all A belongs to A, right? This implies minus alpha is lower bound for A. Is that okay?
Yes, ma'am.
Means using supremum we have to come towards infimum. So we have assumed alpha is supremum and we come to the, means we have found the lower bound. Now let beta be lower bound for A. Then beta also less than or equal to A for every A in A, right?
Yes, ma'am.
Yeah. So what can I say about minus beta? Is greater than equal to minus A for all A in A. So this implies minus beta is an upper bound for which set? For the set which set? Minus A. Minus A साठी ना? Are you
Yes,
getting
ma'am.
this? Yes. It is not. Are you getting my voice? Are you getting my voice?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes. So minus beta is an upper bound for the set minus A. But what about alpha? What about alpha?
Those are equal.
No, no. Minus beta is an upper bound for the set minus A, since alpha is equal to
Phi minus
supremum of minus A. We must have, what is the relation between alpha and beta minus beta? Alpha is least upper bound.
less than
Alpha is least upper bound. So it must be less than or equal to minus beta.
minus.
So what this implies? Minus alpha is greater than equal to beta. Minus alpha is greater than equal to beta. Then minus alpha is greatest lower bound of A. Beta is lower bound of A. Beta. Beta is lower bound for A. And minus alpha is
Greatest lower one.
again lower bound for A. But we are having minus alpha greater than equal to beta. So minus, this implies minus alpha is greatest lower bound of A. So what this gives? That is minus alpha is equal to infimum of
Minus.
A ना A. A इथे A होता ना, minus beta is an upper bound, beta is a lower bound for A, minus alpha is a, you can see here, minus alpha is lower bound for A, beta is lower bound for A, and we are having a relation minus alpha is greater than equal to beta. So minus alpha is nothing but GLB of A, that is nothing but infimum of A. But what is alpha? What is alpha?
Supremum of minus. Minus A.
This is nothing but supremum. That only we want to prove, minus supremum of minus A is nothing but infimum of A. So supremum, that is supremum of minus A is nothing but minus infimum of A. That only we want to prove. Is that okay?
Yes, ma'am.
Yes, ma'am.
Okay. Now we prove theorem. Every monotone bounded sequence of real numbers is convergent. Every monotone bounded sequence of real numbers converges or convergent, you can say. Converges, we will say. Instead of convergent, I will write converges. Real number, every monotone bounded sequence of real numbers or is convergent. Okay, no problem. So So let xn be a monotone and bounded sequence. So what is monotone? What is mean by monotone sequence? Either it is increasing or decreasing sequence. So first we will prove this theorem for increasing sequence, and then from that we will prove it for decreasing sequence also. So let in proof, let xn be an increasing and bounded sequence in R. So if it is bounded sequence in R, let xn be bounded monotone sequence in R. First we will prove for firstly we assume xn is an increasing sequence. So what can I say about this set? This sequence is bounded and it is an increasing sequence. So what can I say about this set? This implies, what can I say? Why it is stuck? This implies xn is bounded above subset of R. Can I say like this? Xn is bounded above subset of R.
Yes, ma'am.
So
Yes, ma'am.
by I will write by completeness axiom, by completeness axiom, it must have or supremum exist. Say alpha or say x, we will say x, supremum exists, say x. By completeness axiom, for this set supremum exists and say it is x. I want now my claim, now I am claiming this xn converges to x. I want to prove that now this increasing bounded sequence converges to its supremum. Okay, up to now it is clear.
Yes, ma'am.
Yes.
Yes, ma'am.
So if I want to prove xn converges to x, what I want to prove? For every, I have to start with arbitrary epsilon, and we have to find a natural number such that mod of xn minus x is less than epsilon for all n greater than equal to n naught, right?
Yes, ma'am.
Yes, sir.
So can you start with arbitrary epsilon? Let epsilon greater than 0. So for this epsilon, what can I say? Since x is equal to supremum of xn, what can I say about x minus epsilon? X minus epsilon is not an upper bound. Upper bound of xn, n belongs to n of this set. Is that okay?
Okay.
X minus, since x is supremum, if I subtract something greater than 0, it won't be an upper bound because x is my least upper bound. Okay. So x minus epsilon is not an upper bound of this set. So if it is not an upper bound, what can I say? There exists k belongs to n such that x minus epsilon is strictly less than xk. It is not an upper bound means there exists element in this set which is strictly greater than this x minus epsilon.
Yes, ma'am.
Yes.
Yes, ma'am.
Now let n greater than equal to k. Since xn is an increasing sequence, what can I say about xn and xk? For all n greater than equal to k, what can I say about xn and xk? Greater than equal to or less than or equal to? xn is an increasing, greater than or equal to xk for all n greater than equal to k. So this implies x minus epsilon is strictly less than xk, which is less than or equal to xn, and which is less than x plus epsilon for all n greater than equal to k. Can I write like this? Yes. So what this implies, x minus epsilon is less than or equal to xn, less than, or I will write here, is less than xn, less than x plus epsilon for all n greater than equal to k. This implies mod of xn minus x is less than epsilon for all n greater than equal to k. Right?
Yes, ma'am.
Yes.
So what this gives? We have started with arbitrary epsilon and we have found a natural number k such that mod of xn minus x is less than epsilon for all n greater than equal to k, or n naught. Instead of n naught, I am using now k here. Okay. So what this implies? xn converges to x. Is that okay?
Yes, ma'am.
Yes, ma'am.
Now if it is decreasing, now suppose xn is, we have proved for increasing sequence. Now I want to prove the same theorem for decreasing sequence. So suppose xn is decreasing sequence. If it is decreasing, then what can I say about minus xn? Increasing sequence. It will be an increasing sequence, and just now we have proved if it is increasing and bounded sequence, if xn is bounded, what about minus xn? It will be also bounded sequence, right?
Yes, ma'am.
So bounded and increasing sequence, by above theorem, it will converge to its supremum by above whatever we proved. It will converge to its supremum minus xn converges to supremum of minus xn, right? but minus xn but what is the relation between supremum of minus xn and infimum of xn? Minus infimum of xn. So this implies xn converges to infimum of xn. Is that okay? If it is decreasing sequence, xn will converge to its infimum. Is that okay?
Yes, ma'am.
Okay, so tomorrow we will prove nested interval theorem. For today, this much is enough.